All right, kids, we have talked about a lot of different things with quadratic functions, but we need to talk about x-intercepts. We've talked about y-intercepts, vertexes, and so forth, but we haven't talked about these x-intercepts. So today, we're going to learn how to find the x-intercepts of a quadratic, and we're going to find them by using our calculator as well. So that'll be very fun. No meme for today, so instead we'll just get the word meme with a frowny face expressing our discontent. I need to let you know that there's some equivalent vocabulary. Sometimes the book will say find the x-intercepts, and this is something that you know where it crosses the x-axis, where the parabola crosses the x-axis. You may also see the term 0, and that means exactly the same thing. And you may also see the term root, which means almost the same thing, but for our purposes, it can basically mean the same thing. So any one of these three words, they all mean x-intercept. In other words, where does the parabola cross the x-axis? So let's take a look at our first example. Now, for each of these problems, I have graphed them already. Sometimes it can be a really good idea to graph these problems in your calculator. And if we graph this parabola, this y equals x squared minus 3x minus 10, it's really easy to see where it crosses the x-axis. Look, it crosses right here at 5, so that's over 5 up 0. And it crosses right here at negative 2. So interestingly, this parabola has two x-intercepts, but that makes sense because it's kind of a U shape, so of course it can touch the x-axis twice. Now, even though I've graphed it and these were very easy to find, like I've already done it, I may ask you to do this with math rather than just graphing. So, what you need to do is, we know that every x-intercept has a y-coordinate of 0. So what we're going to do is we're going to replace the y with 0. So 0 equals x squared minus 3x minus 10. Now, this looks like an equation from the last chapter, right? Here's a polynomial equation. I have my 0. In order to solve for x, because I have the square, the next step is to factor. So I got my 0. Let's go ahead and factor this. I think it factors to x minus 5, x plus 2. Yes, factoring has not gone away. And then the final step is 0 product property. We'll say, hey, 0 could equal x minus 5 individually. If I add 5 to each side, x would be 5. Oh, look, that was an answer I got. Or if we set 0 equal to x plus 2 individually and subtract 2 from each side, x would be negative 2. And look, that's what I got over here. So it works. All we have to do is plug in a 0 for y because each of the y coordinates of every x-intercept is 0. And then I can solve, okay? So let's look at a couple more examples, then I'll show you how to use your calculator. Second example is this one. I have a function, and I graphed it, and I'm looking for the zeros. Remember, if I see 0, just think x-intercept. It means the same thing. In fact, the way 0 got its name, I think, is for the fact that eventually, if we want to solve this, we're going to replace y with 0. We'll take a look at what's going on with this parabola. It doesn't just straight up cross like the other parabola did. What this parabola does is it goes down and it just barely touches the x-axis at the point negative 3, 0. So while we had two x-intercepts in example 1, right here it looks like, because the parabola is just touching, we only have 1, 0, or one x-intercept. Interesting. And let's see what happens when we actually do the math. Remember, in our equation, since I know that the point is going to have a y-coordinate of 0, because that's what an x-intercept is, so I'm going to replace y with 0 and solve for what x equals. And if I factor this, I find that this factors to x plus 3 times x plus 3. So do you see what's going on here? If I set this one equal to 0 and solve, x would be negative 3. But same thing here, x would equal negative 3. It's like a duplicate solution, and what that looks like on a graph is just 1, 0. Interesting. There's one other thing that can happen. So in example 1, I saw 2 zeros. This is pretty common. In example 2, I saw 1 0. This is not common at all. It's pretty rare. Only special cases. Here's another example though. Take a look at this. What are the x-intercepts here? Well, look what happens with this parabola. It goes down. Its minimum point is right here at 3. That's actually the y-intercept. But then it goes back up. Does it ever touch the x-axis? Well, no, because its minimum point is 3. It never goes any lower than 3, so it never even gets to the x-axis. So there are no x-intercepts. There are none. And that's a possibility too. If you look, you can't factor this. It's not factorable. We will learn some ways of solving without factoring later on in the chapter. So it's not no solution or no x-intercepts because it can't factor. We're going to look at some other ways of solving later on, and even those will also result in no solutions. So let's just review what our parabola could have. We could have 2 solutions, we could have 1 solution, or if the parabola reaches its minimum value before even getting to the x-axis, there could be no x-intercepts. All right, so these are all the very easy examples where the math works out perfectly. Let's take a look at an example like number 4, and here's where you're going to need to pull out your calculator because your calculator can actually find these for you, and I'm going to show you how to do that. So this calculator, this parabola, it clearly crosses the x-axis here and here, but it's not clear exactly where. Like, is this 2.4? Maybe. Is it 2.3? The point is, I don't know. And if you look at this, it's actually not factorable. Like, if you really care, you can pause your video and try to factor this for a little while. It won't work. There is no way to factor it that I can see. So let's go into the calculator. I have no other options. And let's go into the y equal menu. I've already put the function in. Let's look at the graph. And the graph should end up looking pretty much like it does here. And yes, it definitely does. So here's what we're going to do. There's a very specific set of keystrokes, and I'm anticipating you being totally lost if you don't pay attention here. So definitely take notes on what these keystrokes are. You're going to hit second calc. And the calc button is the button right next to the graph button. So I don't know if you can see this little white dot. Here's the graph button. Right next to it, it says trace, but in blue, calc. So second calc. Now, which one might we want to use? We're looking for x-intercepts. We're looking for 0. So let's do the 0 function. Now, our calculator is going to prompt us for a left bound and a right bound and a guess, and I need to tell you what these things are. Let's say we're trying to solve for this 0 first. Our calculator can only do it one at a time. What we need to do is we need to move that little cursor on our calculator back and forth until it gets to a point that is left of the 0. So let's take a look here. Right now my cursor is to the right of the 0, but if I keep going left, now I'm to the left of the 0. So right now, if I press enter, this gives me a left bound, and I pressed enter right about here. My cursor was here. If we draw a vertical line, we see that this is a boundary to the left of this 0. Now the calculator asks me for a right bound, because the calculator is actually kind of guessing and checking here. It's not actually able to do this exactly. It uses a clever algorithm to guess and check, but we need to help it. Look, I'm taking my cursor up. I actually put it right on the y-axis. So if I hit enter here, this is a right bound, because look, if I draw a vertical line through, this is to the right of the 0. So now my 0 is in between the right bound and the left bound. Finally, the calculator needs a guess, so put your cursor as close to the 0 as you can get and hit enter. This is your guess, and the calculator says that this 0 is negative 0.85, we'll round to 1, 0. So that's the first one, but we also need to find this second 0. So I'm going to need to use the calculator function again. So again, hit second calc. You want to go down to the 0 function because we're finding zeros. And again, you need to give it a left bound and a right bound. So my left bound, I want to put somewhere over here, because if I'm trying to get this, I need to do a point to the left of it. Here's a point to the left of it, right about here. That's good enough. Now we need to give it a right bound, so something over here, that'll be to the right of the 0. So let's arrow my cursor over. Okay, good, that's a right bound. Finally, it asks for a guess, so just try to put it right on. That's close enough. And the calculator tells me that that exact point is 2.351, 0. I don't know if you can see it, but it's on the display showing. Now, if you didn't have your calculator out and you didn't do that with me, what are you thinking? Go back and do it again. Make sure you come into class prepared to do this, because I guarantee a lot of people will be lost because they didn't pay too close attention. But that's how you can use your calculator to calculate zeros. Pretty cool, and it's a really good way to check your answers in this chapter. Anyway, thanks for watching. I think I might catch a little of the Real Bayern game.